Hello everyone. In this video, we'll be diving into a Python script that uses the power of libraries like Pandas, NumPy, and Yahoo Finance to analyze the historical stock returns of Apple company. We'll walk through each step of the code, explaining what it does and how you can use it for your own stack analysis. All right, so if you have not installed libraries which are required for a project, you have to install them first. So here we import, first of all, install 4 essential libraries, Pandas, NumPy, YFinance, and Datetime. So the code for installing required libraries is pip install. The name of the library, as I said, Pandas. Because we are going to install several libraries, we can put the name of all of them down here. Pandas, NumPy, Datetime, and YFinance. So as you see, the requirement already satisfied, which suggests these libraries have been installed in my computer before. That's why I received this message indicating that requirement already satisfied. If you have never installed them, or it's your first time that you are installing these libraries, you most likely receive another message suggesting that these libraries now are installed. Once you install library once in your machine, you don't need to reinstall them again in future. Okay, so for any project, for any script, you need to just call libraries to your project. For this purpose, what we can do is to import them. So here we are going to import 4 libraries. So we say import pandas as PD. And the reason that we use abbreviation is that's much more comfortable to use abbreviations rather than the names in coding. So we are going to import pandas as our library as PD, which means that from now onward, instead of typing pandas, we are going to type just simply PD. So we can add more libraries here, or import more libraries. Import NumPy as NP. Enter. Import YFinance as YF. Enter. And import Datetime as DT. I just repeat myself again. If you have installed these libraries before, you need to start from the second cell, which is here. If you have never installed these libraries, so you have to install them first. Okay, so let's run. So as I said, Pandas, NumPy, YFinance, Datetime. In most cases and projects related to the finance and machine learning, we need these 2 libraries, Pandas and NumPy. Pandas basically is a library for data manipulation and analysis, and NumPy is for numerical operations on arrays. And YFinance is for fetching actually historical stock data from Yahoo Finance. And Datetime is a library used for working with actually date and time. Okay, so now the libraries are installed, imported into our environment. So let's go to the next step. In the next step, we are going to basically fetch stock data or get the data from Yahoo Finance. So by using hash, you can put notes for yourself or comments for future reference. So I'm going to tell, for example, I'm defining the stock symbol, start and end dates. So this is what I am going to do in this specific cell. So ticker for Apple is basically AAPL. You can refer to Yahoo Finance. If you go to the Yahoo Finance website and search for Apple as company, you see the symbol for Apple is AAPL. Our object here is to download historical data, right? So historical data, the last 5 years, daily historical data of Apple. So for example, the last 5-year historical daily apply, right? So as you see, we have got the prices of Apple, stock of Apple, 1st of February. It's been 186.86. Go down to the last 5 years, historical data are available. So one way to actually upload this data to your Python area is to download it from Yahoo Finance. So as you see, it will be downloaded, and then you can upload it, actually upload this CSV or Excel file into your Python area. The other way that we are trying here today is just basically we want to bring this data directly to our Python without actually using CSV or Excel file. That's why we are using this package, yFinance, which facilitates bringing data from Yahoo Finance. So the ticker is Apple. So ticker is basically the symbol of Apple in the stock exchange, right? And also we need to determine the start time and end date. So I'm going to use package DT, which is actually daytime. And as you see, different functions of this package pops up. So I'm going to choose datetime itself, which is a function in the package datetime. For any function, you need to open, close brackets. And here, what we need year. So let's say 2018, comma, February, let's say 1st, up to dt dot datetime 2024 to, like, say 31st. Okay. All right. So we are in the, yes, 1st of February. Let's say 1st of February 2024. So we want to download data from 1st of February 2018 to 1st of February 2024. Okay, enter. So here we are going to fetching historical stock price from Yahoo Finance. All right, so I'm going to call the series price is equal to the library we are going to use is YF, which is Yahoo Finance dot. One of the functions is download any function, open, close bracket. We need ticker, comma, start date. In our case is the start. So this function has got some items which we need to fill them, including ticker, the comma, a start time, which we already defined as a start, and end time, which we defined it as end. All right. And also we need to determine the interval. The interval, as you see here in the instruction of this actually function, we need ticker, start, we need end time, and we need interval, which is an string value, all right? Because it is a string value, it should be inside quotes. So interval would be one day. All right. So these kind of features are predetermined by the actually producer of this package. So these cannot be changed by us. And it means that if you want daily actually price, you need to put 1D. This is not something that we decide how to put inside, right? So if you back to the instruction of this code, all right? We'll try it again. Yes. So the instruction is completely clear what we need to put here. It says interval should be string. In case of 1 day, should put 1 day, for example. So if you want, see, valid periods are 1 day, 5 day, 1 month, 3 months, 6 months. So if you want, for example, yearly data, you need to put Y, 1Y. If you want to download the data from specific date, you need to put the date in this format. So we cannot create things from ourselves. We need to follow instruction of any actually time function in our library. So that's why we put 1 day like this. All right, so, and then if we execute this cell, the price would be downloaded. But if you want to see it as an output in our collab, you need to type it again. So price, let's see. So it looks that I have got some error somewhere, and the problem should be in TK. It gives me error. It's a very common thing. When you do coding, you would receive some errors. So we need to try to figure out what is the issue here. Yes, unexpected. All right. Let me bring it back. It looks that, yeah, we shouldn't put space. All right. So as you see, the code is running. And it takes time to be executed. Is downloading data from Yahoo Finance. So we have got our data, 100% is completed. As you see, we have got data from 1st of February 2018, open, high, low, close, adjusted close. But what we need is just adjusted close price. So see, we have got a matrix of, or we have got a data frame, including rows and columns. We want to separate this column from this data frame. So how we can do that? When we want to exclude specific columns, we need to use square bracket. And because we are ordering basically Python to exclude adjusted close price, I'm going to put it inside quotes again, right? It's not a number, it's a string. That's why it should be inside quotes. So again, to exclude columns from data frame, we need to put the name of that columns or column inside this bracket. And then let's run it again, see what we have got. This time we have got price. And as you see, we have got just adjusted closing price. All right, so we downloaded adjusted closing price. can try to see the first 10 or the last one. I think it was tail. Yes. So the last 10 observations or the first one head. By default, Python shows you the first 5 and the last 5 observation of each series, right? And also you can use function print price. It does the same thing, right? Okay, so now we are going to calculate the returns. So I'm going to define a new cell as text, and I just put calculating returns, okay? Always try your best to be as neat and organized as possible when you are writing codes. And the reason is that later on, you might need to back to your files and scripts in order to check what's going on. But remember, if you don't want to execute the specific cell, you can simply put hash in front of the code. And this time, that line of code won't execute it, all right? So because usually, as I said before, libraries would be installed once and forever. You don't need to execute this code when you run this basically script. That's why I put hash here. But we need to import libraries definitely. All right. So this is how we can get rid of re-executing a line of code if you don't like it. Okay, so calculating returns, I'm going to calculate the return of this series, daily return of the Apple stock. And all right, to calculate the return, I'm going to create a new series which called return. And there are different ways you can do it. You can use calculate daily return using discrete approach. So we have got price, the series of price. You can say, okay, use a function. This is a predetermined function available on Python. So you have got a series. You can use this function, PCT underline change. All right. So what this function does, percentage change between the current and prior element. So basically computes the percentage change between price today, price yesterday. So PCT change is the function we can use. It is a pre-installed function in our library. So price.pct change. So if I type it again, so see what we have got here. See, we have got daily change in the price of Apple, right? And this is basically a simple discrete interest rate, which is actually price today minus price yesterday over price yesterday, okay? Also, we can use logarithm return, which is more accurate approach. And most of financial analysts prefer to use logarithm. So we can say, we can use, because we are going to use logarithm, we are going to use the package numpy and function log in this package. So remember, NP stands for numpy dot log. So I'm calling the function log from this package, and price today over price the day before, price dot. In Python, we use shift. 1. So this price refers to the price today, and this price shift refers to the price in the day before. So we are taking logarithm to calculate log return. All right. So print ret, and also I can say print log ret. So this is the ret, and this is log ret. And as you see, the numbers are very close, but not equal. And the reason is that this is a continuous change and return, and this is actually a discrete change of the price or discrete return. All right. So here we are going to display descriptive statistics of return. And for this purpose, we are going to use log ret. This is our series, calculated series. Simply, you can say describe. Again, describe, generate descriptive statistics of your series of observations. So as you see, we have got number of observations, their mean, standard deviation, minimum, maximum, and different percentiles. Also for visualization, we can use plotting. So I'm going to plot the logarithm log return basically. And so we have got our series, which is log return. And we can use function plot, Control Shift, and it would create this graph, which illustrate actually changes of the Apple price or volatility of Apple price return per day in the last 5 years. So as you see, we have got high volatility in 2020, and that refers to COVID period. We can change the size of this plot. So there is a item here, fig size. So the fig size, like say, we can say, for example, 10, 5. So we can moderate the size of this figure here, like for example, change it to 8, 4 to make it smaller or larger. All right. And next, we are going to calculate the summary statistics, what we need actually log return daily. So we want to know in average, how much has been the daily return of Apple, all right? So log return, underline D. So I'm calculating the average of daily return of Apple. So we have got the log ret as our series dot mean. So by mean function, we can calculate the average of daily return. So let's see what is the answer. So our answer is 0.001. So this is daily return of Apple, the average daily return of Apple, which means that in the last 5 years, in average, Apple earned 0.001 per day. Now we want to convert the daily return to yearly return. So we can say log of return annually is equal to log return daily times 250. the number of trading days per year. So log return yearly would be equal to 25.47% per year. Okay. And now we want to calculate the standard deviation, which is the measure of risk. All right. So first of all, let's try logarit daily standard deviation, STD. All right. So we have got log return of Apple. We already calculated that one. This is a series. Dot STD. So STD is a function to calculate a standard deviation of our series. And let's see, what is the number? Yes, 0.02 or 2% is the average standard deviation of the Apple per day in the last 5 years. So we want to convert it to yearly standard deviation. So log return yearly STD would be equal to log return daily standard deviation times this time NP SQRT 250. So to convert daily standard deviation to yearly standard deviation, we need to multiple daily standard deviation times a square root of 250. And we can see what would be the yearly risk of this company, which is around 31%. All right. So as you see here, this script provides a comprehensive analysis of Apple's stock return from downloading data to visualization and summary statistics. Feel free to modify it for your needs and explore other aspects of financial analysis. Don't forget to install the necessary libraries at the beginning if you haven't already installed. Thank you.